Hello everyone, in this video we are going to learn about the symbols which are used before or over or after the dimension numbers. So this is a dimension number and we are using this symbol here, and this symbol denotes something. So we will be learning what these symbols actually denote. So let's start from the first. This is the diameter, and a phi symbol is used to denote the diameter, and diameter is used when there is a complete full circle. To denote the dimension of that, we use phi, the diameter. And then is the radius. Radius is used when there is not a complete circle and we have to denote the radius. So we use R in capital. And then are the spherical diameter. Spherical diameter is used when we have something in spherical shape. Here you can see it is spherical, so in order to denote its diameter we use S phi, S before the phi. It denotes that it is a sphere. So the next one is spherical radius, just similar to the spherical phi, which is more clear here, SR. And as you can see on this edge, this is spherical, so we have used SR and we have given the radius SR20 in this case. Then is the conical taper. Conical taper is, for example, there is a bar, like this is a bar, and on one face there is a taper conical in nature. Let me show you. Yeah, this one. So we have to denote what is the ratio of this taper. So this one, for example, if this height or this depth is 1, then this length is 6. So 1:6. So conical taper 1:6. That has been denoted here. Then the next one is a square. A square is used, the square symbol is used when all the sides are equal. As you can see here, they are all equal, so we just use this square symbol and denote as 12. Means the edge of one side, because all the edges, all the sides are same, so just telling 1 is sufficient. So square 12 in this case. Then is the feature repetition. For example, 2 into x, 2 or whatever number of times the feature has been repeated. This is basically used in the holes which are equally spaced, so we also write equidistant. In this case you can see the holes are 6 in number and they are at equal angle with each other, so we have written 6 because they are 6, so we have written 6x phi 30. Phi is the diameter of this hole and 30, phi 30. And then we have also showing this angle, and this angle is 60 degree, and since this is the same for each of them, so either we can write here equidistant or we can write 6x 60 degrees, which means that this is 60 degree. Then if we draw an angle from here and this one, then this is also 60 degrees. So all these angles are 60 degrees each. So 6x 60 degrees. Now let's go for the linear array. This was for the radial, or you say circular array. Now for the linear array, you can see this is the whole and these are 4 in number. So 4x 30, 4x phi 30. There are 4 in number, so 4x. And then distance between them, they are equidistant, and the distance between them is 50. And since if there are 4 features, then the distances between them will be 3. 1, 2, 3. If there will be 5, the distances will be 4, or you can say less 1. So 3x50, we have written this as 3x50 for the distance. So this is the feature repetition. Now is the counter bore. For example, we have drilled up to middle, or we have not drilled throughout and we have made a blind hole, or we have made a counter bore. Let's move upward to show you. Yeah, this one. So this is the counter bore. So in order to show this counter bore, we are using this symbol, and you can see this is just similar to this counter bore. 540. Phi is the diameter of this counter bore, and this is a counter bore. This is not a thorough hole. Then is the countersink. Countersink is similar, but with just a difference that it is conical in nature. It is a kind of a conical hole. As you can see here, it is conical in nature. So we will be writing 537 into 82 degrees. To define any other side or any other feature, we also use the x 82 degrees. So this denotes the angle, and 30 here is the diameter of this inner one. And then is the depth. To denote the depth, we use a dash or a minus sign, and then there is an arrow pointing downwards starting from the middle of this dash. So here in this case it is 20 mm deep, and from the surface it is that we are looking at it from the top, or actually we are above the drawing. So for us this is the depth, so we are using it beneath the this one and this depth sign and 20 before it. That is the actual length. So this is the depth, and this is the spot face. Spot face is basically used for washers. So here we this is the 530, and then this counter bore sign, which means that up to certain length, this is the basically this is the diameter up to certain depth, and we can also define the depth. We can write it like that here. The next one is reference. We are starting from some datum point or from a reference point, then we use this to denote that. Then not to scale, we use dash or minus sign. Then is the slope. To show the slope, for example, this is a block, and it is 1 mm here and 10 mm in the length, the slope. So we write the slope sign, and 1 is to 10. The next one is arc length. Arc length is actually, this is an arc, and we are not measuring the distance, the straight distance between these two. We are basically measuring the length of this arc over this, which is also portrayed here. So we use a sign like this, as you can see here. So this is the arc length, and there are certain other things remaining. And this is the angle projection, which I have already told you. Third angle projection or first angle projection, equally it would be shown here. And then is the center line. So C, a small c, and an L is crossing the vertical line of L is crossing this. So this is the CL. So if the line is vertical, it is by the side of the line, and if the line is horizontal, it is inside the line. So this is the center line. All else is clear.